Hello everyone, welcome to this video. In this video, we are going to discuss about first bad version. Um, so the problem is you are a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, all the versions after a bad version are also bad. Suppose you have n versions from 1 to n and you want to find out the first bad one, which causes all the following ones to be bad. You are given an API which returns whether version is bad. Implement a function to find the first bad version. You should minimize the number of calls to the API. So this is an easy problem because, for example, let's discuss about the example one. Here is given n is equal to 5 and bad is equal to 4. So n is equal to 5 means we have numbers 1, 2, 3, 4, 5, and uh, the output is 4. It means that 4 is the first bad version, right? 4 and after 4, all the elements will be bad. Okay, this is what we do in our in this problem. And this problem is about so let's take another 9, 10, 12, 14, 18, right? So so here, if 12 is the bad version, all the elements after 12 will be bad. So the result will be 12, right? As this is the first bad version. Okay. Um, One thing to note here is this is given in an increasing order because here in the question is given that all the versions. So in the software, what we do is we have versions that version one, 2, 3. So the version which is now current version will be greater than the previous version. So it will always be in a sorted order or an increasing order. Uh, 1, 2, 3, 4, 5, right? So if 4 is the first bad version, we can easily find out by iterating from left to right. We'll check for 1, 2, 3. Till here, nothing bad. A number has we have it has occurred to us. But when we reach 4, we print 4. Simple. But in the worst case, it may take O to the power n complexity because if we go to 5, if suppose the first bad version was given 5, okay, so we would have to go from here to here, then we would have to check for 5 also, as this is the first bad version. So the total number of elements in the array are n is n. So we would be checking for O of n in the worst case. Okay. So we have been given a condition that this is a sorted array, right? So we it hint that we can perform. So yeah, it just gives us a hint that binary search can be performed because we have to search for an element, right? So let's see whether we can have a binary search here or not. So suppose 1, 2, 3, 4, 5. Okay, here it's given like this. So in the binary search, what do? We first check for the middle element. Okay, so the middle element will be 3. That's right. We check for 3 whether it is bad or it is not bad. So here it's not bad. Okay, so if it is not bad, it means that the elements before 3, they will also be not bad. Okay, right. If it was bad, then this would uh, then the 3 and the elements after 3 would have been bad, but the elements before 3 might be bad and might not be bad, right? If 3 was a bad version, okay, If 3 was a bad version, so there are two possible scenarios. The first one is mean that this is the first version. The first scenario. Second scenario is that this is not the not the first bad version. Okay, so if it was the first bad version, then the life would have been simple. It would have been the answer. But if it was not the first bad version, then we would have to check for uh, the elements before 3, that whether 2 could have 2 was the bad version or not, or 1 was the bad version or not. So we would not have been satisfied with the 3. Okay, so here 3 is a good version. So we will not check for 1, 2, 3, as we'll go forward, we'll check for 4. Okay, so now what we'll do in the binary search, we have low pointer, we keep high pointer, and this was the mid, right? So what we will do is from here, we will have, as this is the good version, we don't have to go left, we have to go right. So in order to go to the right, we have to move low pointer after the mid. Okay, after the mid. So the low pointer will come here. Let me draw once again. 1, 2, 3, 4, 5. Now the low pointer is here, the high pointer was here, and the new mid will be this mid, this 4. So then we will check for 4. Yeah, it is a bad version. So we are confused. Okay, so this may be the first bad version or not. If this is the first bad version, then we have the answer. So what we will do is, if we will keep an answer variable and we will write 4, because right now we have this bad version and it may be the answer. Now we have to check for, as 4 is the bad version, we don't know that this is the first or the or not the first bad version. So we have to check for the before elements, right? So what we're gonna do is, low was here, high was here, mid was here. Okay. So what we're gonna do is, we have to go left now to check. So the high would come here. Yeah. And that's it. The high would come in because we have to go left. So as the high is lesser than low, we can say that we can exit the loop and say that, yeah, that's fine. Whatever in the answer we had, we are gonna print it. So we are printing 4. So in this case, it will work like this. So what we can do is, uh, we can have a low as 1, high as n. Then we can run loop from low high, and then so will be running, so and the mid we will have as low, high minus low by 2. Okay, we are gonna check if, so here we are given boolean is bad version API. So whatever number we give inside this function, it will say that whether it is a bad version or not. If it is a bad version, we are gonna save it in the answer, and we are gonna uh, move left because we have to see for the left also. So it will be mid minus 1. Else we will have low is equal to mid plus 1. One thing we forgot, that we have to update the answer also. Answer is equal to, let's say, So this is the thing, and now what we have to do is we have to return answer. We have to return answer. So I think this should work fine. Uh, you can run and see. Yeah, it's running fine. Should run fine. So the time complexity will be O of log n. Earlier we were having O n, right? Now we have taken advantage of binary search and we have done it in O of log n. So that's it for this video. If you have found this video informative, please like this video, share with everyone, and press the bell icon for the notifications, and subscribe to this channel. I'll see you all in the next video. Thank you.